Hey y'all, quick video today. This video is assuming you completely understand everything from the last videos. Like, you want to be able to totally understand how do you write the name of ionic compounds and write the formulas of ionic compounds with those balanced charges. And then you also want to make sure you know how to write the formulas of and name covalent compounds. So in this lesson, we're going to make sure that we can tell the difference between ionic and covalent compounds, and then kind of practice that a little bit. So when we're given a mix of ionic and covalent compounds, we want to be able to correctly name or write the formula of each. And these examples aren't going too crazy. These are just high school chemistry examples. So we'll learn rules that cover those examples. Whenever you're looking at a chemical formula and you're trying to name it, the most important thing you want to do here is, first of all, identify whether the compound's ionic or covalent, because there's completely different naming rules here for the two. You know it's going to be an ionic compound if you have a metal and a non-metal. This includes compounds with polyatomic ions, and sometimes you will not see a metal with your compound here. If you have something like ammonium in the front, for example, NH4Cl, this is ionic because ammonium is a polyatomic ion that would take the place of where metal normally would be. If you have a covalent compound, you'll notice that you have a nonmetal with another nonmetal. So it'll just have two different things together, something like N2O4. You would notice, hey, here's a nonmetal with another nonmetal. There's not too many things here. Unlike here where we had like 3 different things, here we just have 2 different things and they're both nonmetals. So if you have a nonmetal with a nonmetal, you know you have a covalent compound, and then you can name your compound by just using those prefixes we learned about, like mono, di, tri, etc. If you end up having an ionic compound, you need to start thinking about, all right, how do I balance the charges? If I have a Roman numeral, and then you can just name it simply if it doesn't need a Roman numeral. So things that don't need Roman numerals, you do need to memorize these to make this easier, unless your teacher gives them to you during the test. Things that don't need Roman numerals are any metals in group 1, your alkali metals, because they'll always have a 1 plus charge. Anything in group 2, let's say groups here, those will always have a 2 plus charge. So your alkaline earth metals like magnesium, calcium, etc., they don't need Roman numerals. And then we have silver, zinc, and aluminum. They will always have a 1 plus, 2 plus, or 3 plus charge respectively whenever they ionize, so they don't need a Roman numeral. Depending on your teacher, they might also say, hey, cadmium is also a fixed charge, but I won't do that in my class. The metals that do need Roman numerals are any other metal, anything else here. So, anything from the middle of the periodic table is fair game: manganese, iron, cobalt, rhodium, zirconium, vanadium. You probably need a Roman numeral in that name, and you need to figure that out. So let's try these together. We are going to look at some formulas, determine if that compound is ionic or covalent, and then if it's ionic, we're going to ask ourselves if that metal needs a Roman numeral or not. First example here is manganese. Is a manganese with a chlorine. So since that's a metal with a nonmetal, that is going to be ionic. Then we're going to look at manganese, and we're going to ask ourselves, hey, does manganese need a Roman numeral? And yes, it does need a Roman numeral. It's kind of in the middle of your transition metals there. So you're going to look at the chlorine here, and the charge of a chloride ion is going to be 1 minus. It looks like there's 2 of them. So to balance a charge of 2 chloride ions, manganese is going to need a 2 plus charge. So we're going to call this compound manganese 2 chloride, that 2 being the charge of the manganese ion. Next example here, we have Cl2O. It looks like I have a nonmetal with a nonmetal, so this is going to be considered covalent. Roman numerals just don't apply to covalent compounds, so we're not going to worry about that. With covalent compounds, just make sure you're using prefixes and then you're changing the ending to "ide", just like with all our other compounds. So if you have 2 chlorines, that's going to be dichlorine. And if you have 1 oxygen at the end, we're going to call that monoxide. Di meaning 2 and mono meaning 1. All right, next example here, we have Ag3N. Ag is silver, and that's a metal, so we're going to say this is ionic. And then we're going to ask ourselves, does silver need a Roman numeral? And the answer is no. It's one of the metals that have a fixed metal charge. So we're going to name this very simply. We're going to say silver. And then for nitrogen, we want to make sure to change the ending to "ide". So this is silver nitride. Next here, we have PbSO4. Make sure you're splitting this up into 2 different things here. Pb is a metal, and SO3 is a polyatomic ion, meaning this is ionic for sure. You have to ask yourself if Pb or lead needs a Roman numeral. It is kind of part of those transition metals, so we're going to say yes, we need a Roman numeral. So you need to figure out what Pb's charge has to be to cancel out the charge of this ion. If you look up this ion, this is a sulfite ion, and it has a 2- charge. So lead must have a 2+ charge to cancel that out. So we're going to call this lead 2 sulfite, sulfite being that compound there. Next example, we have I2O7. Looks like a nonmetal with a nonmetal to me, making this a covalent compound. Roman numerals not being applicable to that. Let's just use prefixes to describe how much of each element we have here. So 2 iodines means diiodine, and then 7 oxygens would be heptoxide. So we use the prefix hepta, and the A gets cut off because it's next to oxide. Final example here, we have RaSe. Ra is a metal called radium, so this is going to be ionic. Se is the nonmetal selenium. Since radium is in group 2A, we do not need a Roman numeral. So we're just simply going to call this radium and then selenide. So selenium becomes selenide. We're always changing those endings to ides unless it's a polyatomic ion. Notice that with sulfite, we kept the ending as ite. We don't want to change the name to ide. All right, so that's the gist of coming up with the names from the formulas. If you need more help or more details on like how to balance charges and stuff, I recommend you watch some of the other videos where I go in more detail. Now, if you look at a name and you're trying to come up with a chemical formula, you want to use the rules consistently here. So if you see any sort of prefix in the name, maybe not even in the first element, but in front of the second element, you know you're dealing with a covalent compound. And if you're looking at a covalent compound, that means that you're going to use those prefixes to tell you how much of an element there are in that formula. For instance, if you see a pentafluoride, that probably means you're going to have 5 fluorine atoms in that formula. If you don't see any single prefix, or if you see a Roman numeral anywhere, this is clearly indicating that you have an ionic compound. And if you have an ionic compound, you need to balance your charges. Never forget to balance your charges, meaning they add up to 0. I'm going to write that down here. If you see that Roman numeral in your compound, don't forget this is not the number of metal that you have. Never get that confused. That's the #1 mistake students make with these. This is the charge of one metal ion. Okay, not the total like positive charge, not the total metal charge. It's just like if you had one of those metal ions, what does the individual metal ion's charge have to be? For instance, if I have like Cu2O, then in this example, we know that oxygen has a 2 minus charge. And in order to counteract this 2 minus charge, we probably need 2 copper ions with a 1 plus charge, which means that if I'm trying to come up with the Roman numeral here, the Roman numeral is going to be the charge of one of these copper ion metals. So in this compound, this would have been called copper 1 oxide, even though there's 2 coppers and the overall positive charge is 2. Let's look at a few examples and then we're done. So sulfur tetrachloride, excuse me, I need some water. I see a prefix here, tetra, so we're going to use our covalent rules. If there's no prefix for sulfur, you just have one of them. The prefix tetra means you have 4, and then chloride is chlorine, so Cl4 is the rest of that formula. Zinc nitride, no prefixes, so it seems ionic to me, which means you want to look at, each chemical species here. A zinc ion will have a 2 plus charge always. A nitride ion will have a 3 minus charge because it's in group 5A. If you're trying to balance the charges here, you could think of the least common multiple of 6 between those charges of 2 and 3. Or you can swap and drop the charges. Your zinc will need a total of 6 plus charge, so you need 3 of them. And your nitride, you'll need a total of 6 minus charge, so you need 2 of them. So the correct formula is Zn3N2. In our next example, we have another ionic compound. Because there's no prefixes, and we see a Roman numeral. Tin has the formula Sn, and this is tin 4, so the charge is 4 plus. Oxide is O with a 2 minus charge, so if we're looking at the least common multiple between 4 and 2, that's going to be 4, which means we just need 1 tin ion and 2 oxide ions to balance out our charges. So we would write the formula SnO2. Finally, we have magnesium phosphate. This also looks ionic to me. I see a metal. I don't see any prefixes. And I want to look at what each ion must be. Magnesium's Mg. Since it's in group 2, I know the charge must be 2 plus. Phosphate, excuse me, ends with an 8. It's going to be a polyatomic ion, so you want to look at your polyatomic ion's reference. It is a PO4 with a 3 minus charge. So we know the least common multiple between 2 and 3 is 6. So in your compound, you'll have a 6 plus charge, canceling out a 6 minus charge, which means that you should have 3 magnesium ions to get to that 6 plus charge. And you should have 2 phosphate ions to get to that 6 minus charge. And now we'll have a balanced formula. And then you want to put phosphate in parentheses, put the 2 on the outside of the parentheses to indicate you have 2 of those. All right, that's all I really had for y'all. Make sure you work out a lot of practice problems on your own to really understand this. I'm going to bring up on the screen some practice problems that I have. Let's see, do I have them with me? One sec. So some practice problems I have for y'all. Are right here. I'm just going to slowly scroll through this. So if you wanted to work on practice problems straight from this video, you can pause, take screenshots if you'd like. And this is some practice with naming. So there's a few examples right here. You want to identify them as ionic or covalent and then try to name them. And then here is some practice with writing the formula from the name. So maybe identify it as ionic or covalent and then try to come up with the formula. Looks like we're missing some parentheses here. All right, I'm also going to show you the keys to this that I solved. So if you want to check your work, actually I think one of my mentor teachers solved this for me. If you want to check your work, go ahead and kind of look through these answers here. That's the first page. On the second page, formula writing, here are your correct answers. All right, lots of luck in your chemistry studies. I hope this helped you, and thanks for watching.